Work problems. Okay, when working on a task like washing a car, two people can do it faster than one person. But most of the time, two people don't work at exactly the same pace. Imagine, like a 16-year-old washing his parents' car and his 7-year-old brother. The 16-year-old is probably going to be able to wash more of the car than the 7-year-old brother as they work on it together. So what this means is that we have to work with different cleaning rates in the case of cleaning a car, but different work rates. So these are called work problems, and they're all about rates, how fast you can complete a task. So what adds together when two people work on the same task is the rate at which they can do that task. So here's an example. If Jen bakes 60 cookies per 1 hour and Nancy can bake 45 cookies per 1 hour, then even if they were in separate kitchen or in opposite sides of the earth, combined together, they could create 105 cookies per hour. So what adds together are the rates. Let's go through an example problem. Greg works at a conference center. He can clean the entire main hall in 7 hours all by himself. But if he gets help from his colleague Mike, they can clean the whole room in just 3 hours. How long would it take Mike to clean the main hall by himself? So to do this problem, the first thing I'm going to get you to do each time is write out the rate statement. So that would be that Greg's work rate, or in this case like cleaning rate, but I'll just keep it general, plus Mike's work rate. Their two rates together combine to the total rate, the total combined work rate. So I'm going to put some values in so that we can make sense of this. So we know that Greg can clean the entire hall in 7 hours. So he can clean one main hall in 7 hours. So that's the rate. One main hall per 7 hours. Mike, well, we don't know how fast Mike can work. In fact, what we're asked is how long it would take him to complete the main hall by himself. So what we don't know is how long would it take. In other words, it's going to take him X hours to complete one main hall. So how long would it take him to complete the whole thing by himself? But together, even if we don't know how long Mike takes, together we know that they can complete the whole one main hall per, or I should say in, 3 hours. So here are the three rates added together. Greg can do the whole hall in 7 hours. Mike can do it in some unknown number of hours, and together they can do the whole hall in 3 hours. So you can see how what's getting added together is the rates that they can complete this task in. So getting rid of the extras, my equation looks like 1 over 7 plus 1 over x equals 1 over 3. And this is a rational equation that we can solve. We can solve it any way, which way we want. I'm going to solve it by getting rid of denominators, which means multiplying everything by 7, 3, and x. Multiply by 7, 3, and x, and we'll get rid of everything. Or 21x is another way of looking at it. We're multiplying by 21x. So I multiply that in there, and 7's cancel, and I'm left with 3x plus, then my x's cancel, 7 times 3. And on the right-hand side, my 3's cancel, I'm left with 7x. So this looks like 3x plus 21 equals 7x. And let's group our x's together. So I have 21 equals 4x, or x equals 21 over 4. And I'm going to write this as a decimal because when we're talking about time, it doesn't really make a lot of sense to have a fraction. So that's 5.25. So there's my answer just as x equals, but what we really should do is say Mike can clean the main hall by himself in 5.25 hours, or 5 hours 15 minutes if we wanted to, write it in terms of how a clock, how we'd actually say it when we discuss time. So what we actually discovered is that Mike can actually clean the main hall by himself faster than Greg. But what really matters is that together they complete it faster.